All right, so this is the presentation for Design for Manual Assembly, or DFMA. Similar to Design for Manufacturing, the goal is to save money with our designs. And you guys are familiar with the Boothroyd and Dewhurst charts. Those are the charts that we use in order to calculate the assembly and handling time. And so, of course, as the goal is to save money, we know that when we're calculating the assembly time, it can be a hassle for us to do because we have to figure out what the time is for each individual step. And so, in order to reduce the assembly time, it only makes sense that the best way to do that would be to reduce the number of steps, because then that means there's less time. And so, the most important thing that we can do to reduce the number of steps is to reduce the total number of parts. Because if we have less parts, then of course there are less steps to put those parts together. The best way we can do this is either by removing parts that are not essential to the task at hand, or we can combine parts or pre-assemble the parts, make them already put together so that it doesn't take as much time to assemble that part with another part. We have a wonderful example of a gun sight from an American tank. Below, we can see the before picture is a little over 2 hours. We can see that there's a total of 47 parts, 58 steps, and 24 different parts. So we can clearly see there's plenty of pins, jets for location. We can see that that bottom box is not completely put together. And we can see that there's a lot of things connecting parts. And so one of those things that we can do is combine parts, make them already put together so that we don't have to add so many things to it. We can see that clearly being taken place with the remodel of that gun sight in the after. It takes a little under half an hour to put these together. There's only 12 parts and 13 steps. We can see that that bottom box type thing has been completely revamped. There's nothing to put on it, and we're only connecting the top and the bottom part now. So we can see how that's clearly been applied, and we'll break down how we can apply some of these same techniques in our designs to make them easier to assemble. Now, one of those is symmetry, and we've talked about this with manufacturing as well, but when we're designing for manual assembly, symmetry can really help because, as we talked about, we don't want left-handed parts and right-handed parts that only work on one side or another side. So if we have a symmetric part that works on both sides, then it doesn't matter which one you pick up. As the assembler, if I pick up a right-handed part looking just like a left-handed part and put it on the other side, it won't work, or maybe it will work and it'll be wrong later on. But if it's a symmetric part and it works on both sides, then I don't even have to think about it. We can see that here in this picture, how the left and right hand part looks very similar, but that the symmetric part that would work in either case is not much harder to design. We can also see how we can integrate alignment features into part design to make it easier for things to slide into place. We would want to make sure that we chamfer any edges of pins or holes that are location barriers so that we align things correctly. As you can probably imagine, a rod that has a flat end going into a hole that also is flat would be kind of hard to slide directly in there. But if you have a chamfer on both sides, then it would be much easier to align it and slide it correctly in. And we can see that in the far right picture and the two pictures below. The square end is much harder to start on a nut or on a screw and harder to slide for a pin than a chamfer or a chamfer for the screw. Next, here's where we kind of see how design for manufacturing and design for manual assembly can sometimes kind of butt heads. So sometimes it works together, like with the symmetry thing, but here we can see how having a through hole adds plenty of time to the assembly of the same design. So if we have a through hole, now that means that there's a nut and a washer on the other end. So adding the nut and washer adds handling time and adds starting the thread, and that can really add up when we get into it. So of course, the design for manufacturing says put a bolted hole everywhere that you can. Design for assembly says get rid of them everywhere that you can. So it might be hard to try to figure out where to put them and where to remove them. But the thing to remember is that we want to optimize it to where it works best for the system and we can save time on assembly and manufacturing. So we want to include bolted holes where it's useful, but we want to eliminate them if they don't have to be there. The next thing that we want to talk about is how we can integrate those fasteners. And so we see in the picture on the left in the middle, there's a plastic cover with a snap fit. Now, as me, the assembler, I could put that down and maybe it wouldn't work exactly unless I shifted a little to the left or shifted a little to the right. But if I include a fastener like the better image in the center of the page, that fastener is going to make sure that that part is in the right place, meaning that that connection has to be in the right place since the fastener went in. We also want to make sure that some of these parts that we make can't be installed in reverse. So we've talked about how we can make parts symmetrical, and that's the best option we have, because if it's symmetrical, then it doesn't matter how they put it in. However, if we can't make it symmetrical, then we want to make sure that it's impossible to put this piece on incorrectly. Because if they put it on incorrectly, we'll find out much later on down the line that it's backwards, and that would take an eternity. Or they would have to flip it around and try to figure out which side it goes on. So if it's intuitive which side that it has to go on, then that would save time as well. In the picture all the way to the right, we see that that bump in the middle of the two holes shows that that can't be flipped around. It doesn't make sense that it would be on the back face. So designing parts similar to this or with this in mind can make the assembly time much quicker. Lastly, we want to go over a couple of other things, just some key points that we want to keep in mind when we're designing these things for assembly. We want to make sure that it's easy for the assembler to handle the parts. And so if we have springs included, we know that if you reach into a box of springs and you pick one out, you're probably not going to get just one spring. And so the springs that we want to use might be flat and ground so that it's harder for the springs to get interlocked. Or we might even opt for individually packaged or smaller packaged springs so that it wouldn't create such a hassle. Also, we want to provide a line of sight to all the fasteners. If you've ever tried to make something or tried to assemble something together and you can't quite see exactly where you're fastening or screwing in a screw, it can make it a whole lot harder. So we want to make sure that the person that's fastening can see what they're fastening. That way they know that they're doing it correctly. And I'll take a couple of minutes to just go over some of the things that can really complicate the handling of features or parts. If we have overly large parts, then obviously, even if they're not too heavy, it can be really awkward to carry and handle around. Or if it's too small and maybe your hands or fingers are big and you would need tweezers or something to pick it up, then that wouldn't be optimal either. Of course, having slippery or sticky parts can present a pretty obvious challenge to handling. Maybe you can't hang on to it, or maybe it won't stick to what it needs to stick to because it's sticking to you. Sharp edges can also provide a danger, as well as being hard to handle and making the assembler go slower because they're being careful. If there weren't sharp edges, then maybe they could go faster and improve the assembly time. And overly heavy parts, of course, are obvious as well. We wouldn't want anything that would take more than one person to assemble just by carrying it, unless it's required for the application. But if it doesn't need to be heavy, then why bring another person into the mix? All of that and much more, there's plenty of things that we can do to mitigate or reduce the assembly time for manual assemblers. And all of this is here on the PowerPoint. So I encourage you guys to try to apply this information to your own designs. Think about how you would put something together and see if it could be done quicker. And that's all. Thank you.